A good Friday morning to all the students of Somerset Intermediate School. Welcome to your enrichment answer. I didn't get any of my students submit answers to this question, so I don't know how well my students did it, but if you attempted the question, I'm going to explain how you can get an answer, whether you did it the same way or not. It is an interesting way to do it. So the first thing is we have this expression here, which is 72 times 5 to the exponent of x, and 225 times 2 to the power of y. And we need to figure out what exponents this x is and what exponent this y is to make these two expressions, a and b, equal. Well, here's how you can solve it. And we can use something called prime factorization. And what that means is if I think of 72, I can break 72 down into what's called its prime factors, meaning prime numbers that are multiplied together to get 72. Now, just to remind you, prime numbers are those numbers which only have 1 and itself as factors. So, for example, 2, 3, 5, 7, 11, and 13 are your first 6 prime numbers because they only have 1 in themselves as factors. So if I break down 72, I can make 72 into 2 times 36. Now, this 2 here is prime and 36 is not. So I'm going to break down 36 into 2 times 18. 18 is composite, 2 is prime. We break this into 2 and 9, and we break it into 3 and 3. So if I break in 72 into its prime factors, I get that. And if I break 225 into its prime factors, 5 being a prime number, I get 5 times 25. And, sorry, not 25, that's 45. Oopsie daisy. My brain's not working so early in the morning. Oh, poopy darn. So if we grab this, 5 times 45, not 25. 45 is composite. It's 5 times 9 and 3 times 3. So in other words, what we can say is, instead of saying 72, I can say 2 times 2 times 2 times 3 times 3 times 5 to the x. And instead of saying 225 times 2 to the y, I can say 5 times 5 times 3 times 3 times 2 to the y. Okay? So once we have it written that way, we're like, hold on a second. This here can be written as 2 cubed. And this here can be written as 3 squared. And over here, this can be written as 5 squared, because that's what 5 times 5 is. And 3 times 3 is 3 squared times 2 to the y. And once we realize that both of these expressions are equal, then we can say, well, hold on, here's 3 squared, and here's 3 squared. So those kind of cancel each other out in terms of equality. This is 5 to the x, and this is 5 squared. So in order to make this equal, I can make this exponent of x into a 2. And I'll erase it up here too. So now, So now we know the exponent of x has to be 2. And if I go here, 2 to the y and 2 to the 3, that means that instead of being a y, we can make it a 3. So therefore, our answer has to be 3 for the y. So the only values that work for this are x is 2 and y is 3. Now let's go back just real quick and take this expression. And instead I'm going to substitute x as 2 and y as 3. And I'm going to go 72 times 25. Take a calculator. What is 72 times, oh, that's not right. Back it up. 72 multiplied by 25. The answer is 1800. And if I go 225 times 2 cubed, well, 2 cubed means 2 times 2 times 2, which is 8. So take my calculator and go 225 times 8. And the answer is also 1800. So we did achieve the answer using what's called prime factorization. So in this case, x has to be 2 and y has to be 3 in order for expression A to equal expression B. Hopefully you got that right. If you did it by trial and error too, that probably worked, but rewind it again, digest the idea of prime factorization, and it's a great tool to have in your tool chest of math. Go ahead and try the newest enrichment, which is enrichment 4. You'll find the video just after this one. Good luck, and see you next Friday.